Okay, good day, no? Our topic for today is how do we convert a number in decimal system or decimal notation into a binary system or into a binary notation. So as you can see, this is a part of solutions to civil engineering. This is in the introduction part. So why do we need to understand this? So first, no, we really need to understand how a computer reads a number. That is the basic thing. Why do we need to understand computers? Why? Because in numerical solution, uh, it is mostly computers that we use to solve civil engineering problems by doing numerical methods. And that is why this is part of our introduction in numerical solutions. We can do numerical methods in the traditional way, let's say manual computation in paper, but it will take us time. And because of the advent of computers or advent of technology here now, we can exploit or we can use this technology in order we can solve civil engineering problems that cannot be solved analytically. And that is why it is very important that we know how computers read numbers. So, computers, as you can see, can read numbers only in a binary system. Why? Because a computer is made up of lots and lots and lots of switches. We call that transistor. So in a computer, there is what we call a central processing unit, and that central processing unit, like Intel i5, Intel i3, or AMD Ryzen, all of them is made up of different transistors. And these transistors, like I say, it is a switch. It can only be in two states. That is, in a state of on, in a state of off, or in a state of close, in a state of open, in a state of true or false. And lastly, it can be in a state of ones or zeros. So that is what we call a binary system. If it is only one or if it is only zero, true or false. What other things can you give an example of other binary systems so you can think of it? No, it's just two. So since a decimal system can be can be represented by 10 symbols, hence decimal system. So what are these symbols? This is 0 for nothing, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 na lahat ito, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in decimal system, we have 9 states. Okay, sorry, we have 10 states. 10 states. In a binary system, we have only two states, no? So only two states, that is zeros and ones. And that is why we need to understand how we can convert these 9 symbols into just two symbols, because as I've said earlier, that a computer can only be in two states, that is zeros and that is ones. So here, as you can see here, I will erase this one. So as you can see here, the binary system, I will just put it here. Okay. Oh, sorry. Two states. Let's put that here. Okay. Uh, so 0 and 1. Okay. So as you can see here, we have this what we call a binary system that is in two states, that is 0 and 1. So how do we convert it? No? So as you can see, we humans understand numbers through what we call a Hindu-Arabic system. No? Hindu-Arabic numerals. And this Hindu-Arabic numerals, like I said earlier, we have 10 symbols, 0 to 9. Now, how can we uh, transform this number that we as a humans understand so that the computer can understand it, because computers can only know two symbols, that is 0 and 1. So as you can see here, we have this number line. Let's just say a number line. So, if you can see here, since this is just a binary system, it is in the base of 2. No, as you can see here. So, if you can see this one, the very first thing that you can see here in this in the center part is 2 raised to 0, that is 1. Then followed by 2 raised to 1, so on and so forth. As you can see, this is base 2, and base 2 will have this output. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 10, 24. And if I add another 10 raised to 11, that is 2048. So, as you can see here, this is what we call the integer part. So, numbers can also have the decimal part, or what we call the mantisa part, if we convert it into scientific notation or floating point representation. So, this thing here is what we call the non-integer. So, as you can see here, this first part is what we call the integer part. This is the integer part. Integer part. And this one is the non-integer part. Non-integer part. In short, this is the fractional part, or if you can fraction it, no. So as you can see here, we have these two things here, two parts, the integer part and the non-integer part. Now, how can we transform it? So as you can see here, we have this series of numbers, that is numbers with bases of 2. And here we can have also numbers with bases of 2, but with different exponents. So in this right part, we can see that the exponents are in the negative. So 2 raised to the negative 1 is 1/2. 2 raised to the negative 2 is 1/4. 2 raised to the negative 3 is 1/8. 2 raised to the negative 4 is 1/16. So on and so forth until 2 raised to the negative 10. So I just put here until 10 and until 10. So as you can see, we have, I think, 11 plus 10, 21. So I have 21, what we call this, containers. So we can call this a bit. 21 bit or 21 switches. Imagine we have 21 switches, and this is how they are arranged, no? From the center, or this one, the centermost part is this one, 2 raised to 0, and in its left is 2 raised to 1, and in its right is 2 raised to the negative 1. So this is our center, no? But this is also an integer part. So it's just easy to convert a decimal system into binary system. We can look at this one. So imagine these are all switches. These are all switches in a light bulb. So as you can see here, if I will click this one, if I will turn this on, so let's try first putting this one into 0. All of them. So, sorry. So this is 0, and this is also 0. So if all are off, if all switches are in the state of 0, meaning all switches are in false or all switches are in off mode, then you can see we have no, it is empty. Our number is empty. No, this is the decimal. Our number is empty. But what if I will on the switch in 2 raised to 1? So this means that when I on this switch, when I choose to make this 1, our answer in the decimal part, or in the decimal system, will also be equated to what is equivalent to 2 raised to 1. And that is why our decimal system 2 in the decimal system is 2 in the decimal system is equal to 1, 0. So the symbol for number 2 in our decimal system is the symbol 2. This is our symbol. But the computer can only see 1, 0 because the computer does not know what is this symbol. So I hope you understand that. So as you can see, our answer is 1, 0. What if number 3? So let's see this 3. So how can we convert number 3 into binary? So let's try again. So as you can see here, we just only need to add what number should we add to this thing so that we can create number 3. Because as you can see here in this number line, we cannot see number 3. We can only see 4 and 2 and 1 and 8. But if I put 1 here in 4, we can't know it exceeded the number 3. And that's why, as you can see here, 2 plus 1 is equals to 3. And that is why I will turn on the switch under the 2 raised to 0 or 1. So therefore, the decimal, the binary counterpart of number 3 is 1, 1. So do you understand it, guys? No? I hope you understand that converting this number is just uh, switching these things. Or for example, this one, I turned it on, and that is why when I turned it on, this 2 and 1, they are equivalent to 3 decimal places. So let's think again. If I want, what do you want the number? 23. So I want the number 23 to be converted into a binary. So as you can see here, if I'll add 16 and 8, it becomes what? It becomes 24. So it exceeded 23. So the only thing I can do is I will flip the switch. Oh, so I'll off this one. No? I'll flip the switch in 16 plus 4, that is 20, plus 2, and plus 1. So this is what we call 23. So what happened to this one? Yan. So 23. As you can see here, it is 23. So 23 in binary form is 1, 0, 1, 1, 1. Same with these things. Okay? So as you can see here, this is the answer. So how about in the non-integer part? How about we can have, I will change, sorry. So let's try 25.625. Okay. So let's try 25.625. What is this? What is the binary form of 25.625? First, we need to see what is the binary form of 25. So in the integer part, that is 25. That is 25. So let's see what is the binary of 25. So that is 16 plus 8, that is 24. So we only need at least 1 so that it will become 25. So we just flick the switch under the 1, and therefore our integer here is 11001. So how about 0.625, 0.625? How about this one? So as you can see here, we need to understand what are these non-integer parts. So 0.625 is just 1.5 or 2 raised to the negative 1. So we flick the switch under the 0.5. So as you can see, the decimal part becomes 25.5. And we flick the switch in this, 0.125. So 0.5 plus 0.125 is equal to 0.625. So therefore, we will just flick the switch here. And therefore, as you can see, when I flick these switches here, it becomes 25.625. Therefore, our 25.625, our binary form is 11001 0.101. So this is our this is the binary form of 25.625. So as you can see, I have created a simple Excel here where when I flick the switch here, it will convert into decimal. So this is this is a binary to decimal converter. So what if I will flick the switch here in 512? What will happen to this decimal? So we will only add 512 to 25.625. Okay, so I'm sorry. It Yan, okay. So what if I try to flick the switch of all of them? What is this maximum part here? So let's see. I have turned it on all. So let's see what is the answer here. So the answer is, the maximum answer is 2041.9990234. So this is the maximum number. If I will try to convert the decimal system into 2042, our number line here is not enough. So that is why the reason you need to watch the video about my lecture about the bit, or BIT. No? Bit stands for binary digit. So I have another lecture about that. I wish you would watch it so that you can understand that the bits here is not enough. Sorry. I forgot to turn this on. So this is the maximum number that we can input here, so that we can have so that this spreadsheet here can only comprehend. So it's up to 2047.999900234. So if we add another here, so let's say if we add another here raised to 11. So if we had raised number, so this is 2048. Sorry. We can increase the range, but it takes so much bits so that we can add additional range, no? But anyway, this is how we convert a binary to decimal, or to decimal to binary, back and forth. So I hope you understand it well, no? If I turn this off, you just need to subtract 1024. So this is it. So 11111. So if we turn it on again, this is the maximum. So the decimal value of 2047.999 0234 is this is the maximum. 0234375 is this. 111111.111111. So this is the simple explanation of how we convert binary to decimal. So this is a part of our numerical solutions in civil engineering. So thank you very much for listening to my lecture, class.